In this section, we're going to look at inverse functions. If two functions f of x and g of x are defined so that the composition of f with g of x equals x and g with f of x equals x, we say that f of x and g of x are inverse functions of each other. And to clarify this, I have in blue here that f in composition with g of x means you're taking f of g of x. You're plugging the formula for g of x in for each x of f of x. And also, g in composition with f of x means you're taking g of f of x. So you're taking g of the formula, or you're plugging the formula of f of x in for each x of g of x. And paraphrasing this, plugging the second formula in for each x of the first formula results in something that simplifies to x. If this is always the case both ways, then f of x and g of x are inverses of each other. Now here's a descriptive definition of the inverse function. F of x and g of x are inverses of each other if the operations of f of x reverse all the operations of g of x in the reverse order, and also the operations of g of x reverse all of the operations of f of x in the reverse order. Let's look at an example. If g of x is the function 2x plus 1, in g of x we're doubling x and adding 1. Well, if we want to reverse those operations in reverse order, the first thing we have to do is subtract 1 because 1 was the last thing we added. So we take x minus 1 to reverse the operation of adding 1. And then we have to reverse the operation of doubling, which is to cut in half. So f of x equals x minus 1 divided by 2 reverses all the operations of g of x in reverse order. Now, let's look at f of x. Here we're taking x, we're subtracting 1 and dividing by 2. If we were to reverse those operations, the first thing we would do is double, which is 2x, and then to reverse the operation of subtracting 1, we would add 1. So we see that g of x reverses the operation of f of x in reverse order. So we can see that f of x and g of x are inverse functions of each other. They both reverse the operations of the other. Now let's show the composition of f with g of x both ways for these two functions. First, let's look at f in composition with g of x. F in composition with g of x equals f of the function g of x. We plug the formula for g of x into f of x, so we're taking f of 2x plus 1. Well, the function f of x is to subtract 1 and divide by 2. So we take the 2x plus 1, subtract 1, and then we divide that by 2. The 2x plus 1 minus 1 turns into 2x, and then when we take the 2x and divide by 2, it simplifies to x, which is what it should be if they are inverses of each other. Now the other way, where we take g in composition with f of x, this is equal to g of f of x. So we're taking the formula for f of x and plugging into the function g of x. We're plugging x minus 1 over 2 in for g of x. Well, g of x says to double and add 1. So we double that x minus 1 over 2, and then we add 1. Well, doubling it makes the 2's cancel, leaving x minus 1, and then add 1. The 1's cancel, and you end up with x, which is what it should be if they're inverses of each other. We have special notation for the inverse of a function. In the last example, we found that the inverse of f of x was the function g of x equal 2x plus 1. Well, we would call that inverse function of f of x f minus 1 of x. That minus 1 is not an exponent. It indicates the inverse function. So f minus 1 of x equals 2x plus 1. And likewise, we found that the inverse of g of x was the function x minus 1 over 2. So here we would say g minus 1 of x equals x minus 1 over 2. There's a nice procedure for finding the inverse function. And what you do is you take your f of x or g of x, whatever it is, and you replace it with y. That's your first step. Then you switch each x with each y that you have in your equation, and then you solve for y. And whatever you get for your resulting formula will be your inverse function. So let's try this on the example. Find the inverse of h of x equals 2x cubed minus 1. Our first step here is to take the h of x out and just put in y. So we have y equals 2x cubed minus 1. Now, after you do that, switch each x with each y. So we get x equals 2y cubed minus 1. And then what we do is solve for y. Well, to solve this equation for y, we start by adding 1 to both sides. That gives us x plus 1 equal 2y cubed. Then we want to get y cubed by itself, so we would divide both sides by 2, and we get x plus 1 divide by 2 equal y cubed. And then finally, to solve for y, we would cube root both sides, or extract cube roots, and we get the cube root of x plus 1 over 2 equal y. That's our inverse of h of x, and using our special notation, we would say h minus 1 of x equals the cube root of x plus 1 all over 2.